All right, apparently I recorded this video and it wasn't recording, so I'm going to do it again. It should be better the second time here. This goes with part 2 of simplifying rational expressions. So it was 8.1c and 8.1d that we did with our notes, but part 2 is going to focus on the adding and subtracting of radical and rational expressions. And so if you're adding or subtracting, it comes back down to the basics of adding and subtracting in algebra. You need to have what we call like terms. So in order to add and subtract things in algebra, they have to be the same. So like 2 plus 3, they're both whole numbers. You can add them together. They're both integers. Add them together, you get 5. And if you had like 2x and 3x, they're both x's, so 2x's and 3x's gives you 5x's. The same holds true for square roots, cubed roots, etc. So you can't add like 2 plus the square root of x, because 2 is an integer and the square root of x, they're not the same thing. You could add 2 square roots of x plus another square root of x, because now they're both the same. They both have a square root of x, so you get 3 square roots of x. So this is what we're going to be practicing today, that whole idea. So in order to add and subtract rational expressions, you do have to remember a few basic things. First of all, the bases must be the same. If you're adding anything with a base and an exponent, the exponents must be the same as well. And then the radical must be the same. That means that the index must be the same, and what's under the radicand must be the same. So if you wanted to add something, the n and the a and the x all has to be the same in both terms. And if that's the case, then you add or subtract the coefficients. So remember, the coefficients would be like the number that goes out in front of that. So the coefficient is the number out front. So let's see if I can switch this. It stays recording. I think that's what happened last time. So number out front. All right, so I'm going to start with this example over here because right now it is ready to go. I have 2 6th roots of 3 plus 7 6th roots of 3. So I have radicals. The indexes are the same, the radicand's the same, and so I can add the coefficients. So those are the same thing. So 2 of those things and 7 more of those, I have 9 of those. And what are those? Those are 6th roots of 3. So I have a total of 9 6th roots of 3. Now to the left here, as is, it doesn't appear to be the same, but I do have the same index. They're both cubed roots. So in order to add these, I must have the same radicand. So I can simplify 625, and if I can simplify it down to the cubed root of 5, then I'll be able to combine these. So 625 is 25 times 25. And 25 is 5 times 5. And remember, for a cubed root, you need a perfect cube to get out, so you need 3 of those 5s. So 5 comes out. Now be careful, there's already 4 out there, so I'm going to do it up here actually. There's a 4 out there, so 4 that's already there times the 5 that we brought out is going to give me 20. And then we're going to have cubed roots, and there's 1 5 left in there. So now I have 6 cubed roots of 5 plus 20 cubed roots of 5. So 6 plus 20, well, that's 26. And cubed roots of 5. So 6 of these plus 20 more is 26 of them. As long as the radical is the same exact thing, you just add the coefficients. So same, just some more examples here. We have 8 square roots of x minus 3 square roots of x. So we have the square root of x and the square root of x, so those are the same. So 8 minus 3 is 5, and you have 5 square roots of x. So you're only adding or subtracting the coefficients. In B, this looks a little different, but if you just look at the variables and ignore the coefficient, are the variable part or the radical part, is it the same? So I have the same bases, g and h, and I have the same exponent to the 1/4. And so the bases are the same, the exponents are the same, so you can subtract the coefficients. You can do 3 minus 6, or 3 plus -6, get -3, and then the variables stay the same. So -3 GH to the 1/4. Here, I have 5 of these minus 3 of these. Notice how those are the same. 4 to the 3/4, 4 to the 3/4. So 5 minus 3 gives me 2, 4 to the 3/4 left. It's just like if you have 5 calculators, take away 3 calculators. Now you have 2 calculators. Well, instead of calculators, you have 4 3/4. I mean, it kind of makes sense, right? In B on the bottom right here, as is, I cannot subtract them because they do not have the same radicand. What's inside the radical is different. But I do know that 81 can be simplified to 9 times 9, and 9 is 3 times 3 on both 9s here. And it's a cubed root, so I need a perfect cube to get it out, so I need 3. So this would give me 27. The cubed root of 27 is 3. And then the 3 comes out, and there's 1 3 left inside. So 3 cubed root of 3 minus 3 cubed roots of 3. Now, this one throws off some kids sometimes because in your mind you're thinking, well, the cubed root of 3 minus the cubed root of 3 is 0. It looks like you get 0 there. But you have to remember that we have an implied coefficient. These aren't going to just cancel. I need to only add and subtract the coefficients. So 3, and then this is a 1 out front here. So this is a 1. So 3 minus 1 is 2 cubed roots of 3. So the cubed root of 3 doesn't go anywhere. You had 3 of them, take away 1, now you have 2. So be careful when working with problems that have a coefficient of 1, especially when you're subtracting. In C, they're very close. I have a 4th root and a 6 in both. One has been simplified, one has not. They do need to look the exact same before I put them together. So I have 5, x to the 5th is 5 x's. It's a 4th root, so I can take 1 x out. That x gets multiplied with the 2 that's already out there, so it's going to be 2x, and then 4th root, 6 is still there, and we have 1x left back over. Plus, this is an x, so it's a 1x, 4th root of 6x. So just the coefficients are different, 2 and 1. Everything else is the same, and so I can combine them. 2 plus 1 is 3. Everything else stays the same. So the coefficients are the only thing that can be different. Now D is kind of a review. It's thrown in here, doesn't quite match, but I think it's worth talking about. This is the product rule. You have the bases are the same, you're multiplying, so you need to add the exponents. So the base stays the same, and you add the exponent. So you get x to the power of 2 plus the square root of 3. This is again to remind you then that 2 and square root of 3, well, 2 is an integer and square root of 3 is irrational, so they can't be combined. You could give me an approximation as like x is approximately 3 to the 3.7 power, but to give me the exact answer, it would look like that. So 2 plus the square root of 3. The last thing we're looking at is the composition of roots. This is like if you have a root of another root. A root to a root. What you need to do if you see this is that so you have a root, and then you're taking the root of that. So 2 roots inside each other. And the easiest way I think it is to do it is to change it to fraction exponents and then simplify. So we, on the inside of this first example here, remember that if you have the nth root of some number to the x power, then that's that number to the xn power. So whatever your index is on the outside goes in the denominator, and then whatever it has for a exponent goes in the numerator. So in our first example here, we have a square root. So remember the index on a square root is 2. We have a square root of a cubed root of x. So I start from the inside out. So on the inside, I have x to the 1/3. That's x to the first power and the cubed root, so x to the 1/3. Then I have the square root of that, so that raises it to the 1/2 power. Power to a power, you multiply exponents. So 1/3 times 1/2, it's numerator times numerator over denominator times denominator, or top times top over bottom times bottom. So we got x to the 1/6 is our final answer, or that's the 6th root of x. Either one would be acceptable here. Start from the inside. It's the cubed root of the square root of x. So on the inside, you have the square root of x. Remember that the index is 2 for a square root, and the exponent for the 5 is 1. So it'll be x to the 1/2 raised to the 1/3. The 1/3 is the cubed root. Multiply those exponents. We just did that over here, so we get 5 to the 1/6, or the 6th root of 5. Just do one more. Got y to the square root of y, and you have the 5th root of y, the 5th root of the square root of y. Geez, that's hard to say. On the inside, you have the square root of y, which is y to the 1/2, and then on the outside, you have y to the 1/5. So it's going to look like that. 1 times 1 is 1 on the numerator. 2 times 5 is 10 in the denominator, or the 10th root of y. That's it for part 2. So make sure to only add and subtract coefficients. Make sure your bases are the same. Your radical must be the same, and exponents must be the same. So basically it comes down to the whole idea of like terms. When adding or subtracting, the terms have to be alike. Okay, thanks for watching.